Hello everybody and welcome back to the 2000 Cayley paper. We're up to question number 20. So, 20 pairs of integers are formed using each of the integers 1, 2, 3, all the way up to 40 once. So pairs of numbers have two numbers in them, 20 pairs. Yep, we're going to use all 40 numbers exactly once. Okay. The positive difference between the integers in each pair is 1 or 3. For example, 5 can be paired with 2, because 2 and 5 have a difference of 3. It could be paired with 4, because 5 and 4 have a difference of 1. 6 and 5, difference of 1. 8 and 5, difference of 3. So we're creating pairs, but we're only allowed, each pair is allowed to have a difference of 1 or 3. Alright. If the resulting differences are added together, the greatest possible sum is... Okay. So we're trying to maximize a sum here. So I think it's fair to say, I mean, we're going to have 20 pairs no matter what. So we're going to have some 1s and then some 3s. To get the greatest possible sum, it seems kind of clear that we need to get as many 3s as possible. We need as many 3s as possible. Notice, if we take a look at the answers, so 50, that's kind of low. 54, that's a multiple of 3. 56, 58, 60. 60, the highest number we could have. If we had all 20 pairs have a difference of 3, 20 times 3, we would get 60. So 60 really is the upper bound. Now, whether we can get that high or not, I mean, maybe we'll be stuck with 58 or 56 or something like that. That's up to us to show. But at best, in the best possible scenario, if we can get all 3s for our positive differences, then we'll get an answer of E60. But let's see where we go. So we want as many 3s as possible. So if we are trying to get something like 60, we're going to need to just sort of make everything have a 3. So consider 1. Now 1, what can 1 be paired with? It can be paired with either 2, which would give us a difference of 1, or it could be paired with 4, giving a difference of 3. Now we want as many 3s as possible, so let's say we have 4. So we'll pair 1 with 4. Okay, now consider 2. We can't pair it with 1, that's already taken. So it could be paired with 3, which would give a difference of 1, or it could be paired with 5, which gives a difference of 3, and no other numbers. Now we want to maximize our 3s. We're going to put a 5 in there. Am I saying that this is the best way to maximize? Absolutely not. Right now I'm getting a feel for the question. Okay, so I'm just saying, well, 1's on the edge, so there's only one way to get a 3 using 1. Now, it might be that we have to make it so that 1 is paired with 2 in order to get as many 3s as possible. We don't know yet. We're just investigating the question. So 1 and 2 are taken. How about we move on to 3? Well, 3 can't be paired with 2. It's already taken. And it can't be paired with 4. So 3 really can only be paired with 6. Now, fortunately for us, that gives us a difference of 3. So now we've paired the first 6 integers all together, and we have 3s in every single place. So now let's move on. 4 is done, 5 is done, 6 is done. How about 7? Well, 7 could be paired with 4, but 4 is taken. Or 6, that would give a difference of 1, but 6 is taken. So 8 or 10. Because we have to have a difference of 1 or 3. We want 3s, so let's pick 10, and we have 7, 10, and this cycle is going to repeat. So we'll have 1, 4, 2, 5, 3, 6, and we'll get 7, 10, and that'll force us to do 11, 14 if we want as many 3s as possible, and 12, 15, if we want to try and get as many threes. Now, we're only maximizing threes at a local level, and that's very important to understand with questions like this. They're asking us to maximize a very broad sum, all the pairs that we could have. Now, there's a lot of different ways to make pairs. And we do know we need as many threes as possible. And so what we're doing is we're saying pick a starting point and try and get as many threes. But that doesn't automatically mean we're on the right track. It doesn't. Because there might be, with pairs of 20, there's a lot of different ways to pair up the numbers from 1 to 40. And so there might be some weird way of, 8 gets paired with 11, and 29 gets paired with 26, and some other weird jigsaw puzzle way that is not clear to us. It just comes out of the random number of possibilities that actually maximizes the threes. So just because we think we're maximizing the threes doesn't mean we actually are going to get the best answer. As I said before, we're just trying to better understand this question. So, I shouldn't have 11 and 14 here. I should have 8 and 11. My mistake, I jumped up. 8 and 11 and 9 and 12. So it looks like each set of 6 can be paired to get 3 threes. So 3 differences of 3. So we could go up to 18 here, 18 and 15, and we'd have 13 and 16. Notice that once we already have these sets of 6 in stone, when we go and look at 13, 13 can only be paired with 14 or 16. If we want to maximize that, we pair it with 16. 14 and 17, that's the other one. And we could keep going on like this. We really could. So 19 and then 25. And then what's the next one? 31, and that will go all the way up to 36. So let's fill these in. 32 and 35. 31 and 34. Now we've stopped doing sort of the individual computation and we're just extending a pattern. But we can see each pair that we are creating has 3s. Has 3 as the difference. So we're getting as many 3s as we possibly can so far. If we were to just take the numbers up to 36, well, we've got all pairs of 3s right here. So we'd be done with the question and we'd be able to add them up. But we have to go a little further. That'll be 27 and 30, 26 and 29. We have to go a little further because we still have 37, 38, 39, and 40 that we need to pair up. Okay? So right now we have as many 3s as possible. But when we look at these guys, well, 37, we could pair him. He could be with 38 or 40. Now our instinct is to choose 40 because we have a 3, but that would leave 38 and 39 that have to be paired together. Now fortunately that works. 37 and 40, and therefore we get 38 and 39, and that has a difference of 1. So that one does work. We couldn't say 38 and 40, for example, even though we are limited to these options. So that seems like it's best, but we have a difference of 1 here, and we kind of want to try and get all 3s. Now it might be that there's no way to get all 3s, and that most 3s and a single 1 is as best as we can get. But look at what we've got so far. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 3s, and 1 copy of 1. So 19 3s plus 1, that's 58. We think 58 right now. 58 is the best one that we have an actual example of. So we should be answering D, 58, but maybe there really is some weird way to get 60. And we just can't see it. So is that the case? Well, what would always having a positive difference of 3's look like? Okay, what would 1 have to be paired with? It would have to be paired with 4. And if you always have 3's, then 2 has to be paired with 5, and then 3 has to be paired with 6. If we're always getting 3's, we have to have this happen. So 1 will have to be paired with 4, and 2 will have to be paired with 5, and 3 will have to be paired with 6 to get as many 3's as possible. And once those are taken up, we start again. 7 will have to be paired with 10. It's the only other one we could pair it with, because 4 is already taken. So if we had all 3's, we would very much get this pattern, and then we'd still be down to finding a way to get get 2 pairs out of 37, 38, 39, and 40 that have differences of 3's. But we can see that that's not going to fly. 60 can't be done. Okay? It's not enough to say, hey, we got this 58 here. You have to convince yourself, and if this were a written style question, you'd actually have to prove it. You have to convince yourself that we can't get all pairs with difference of 3. There's no way to get an answer of 60. 58 is the best we can do. So I've given you a verbal explanation. If you are interested in that sort of stuff, if you're considering writing the this is the grade 10 multiple choice contest, the Cayley, if you're interested in writing the Galois, try and take my verbal explanation and write out a proof as to why you can never get 60. That's just a little exercise you can do if you want to write some of the written contests. But you don't have to, when you're writing out these multiple choice contests, write out your explanation to yourself, as long as you're convinced. And I would say my verbal or internal monologue explanation has me convinced you can't get 60. So I'm confident in my 58, so I bubble in D. So, good question, and I think that would have been an equally good question if it had appeared on a Galois paper. So the written style contest question. So like I said, if you want to, try and write out a proof as to why you can never get 60. You know, you can go back, rewind the video, and listen to my explanation, see if you can make sense of it. But I think that's all I'm going to do for the question, and we're going to move on to question number 21, so the first in part C. And we'll see that in the very, very next video. So I'll see you guys next time.